Hello, and I'm gonna be walking you guys through binary search algorithm. I'll be using Java. This is gonna be an iteration method. So let's get started. So first, I'm gonna create a array and name it numbers, or excuse me, not name. Yeah, name it numbers. I'm gonna pick any random numbers, but it has to be sorted, so either in ascending or descending order. So I'm just gonna use ascending order. Excuse me. Oops. With the square brackets. Okay. So what I'm gonna do here is initialize I. Then I'm gonna initialize key equals to 0. And then initialize key index to 0. So what key is gonna be what the the key will hold the element inside the array, and I'll explain it as I go along. Okay. So I'm gonna have a for loop that will print out all the elements in the array. That way the user can see the elements or the values that they're given, and if they don't put in that value, if they don't put in the value that they're given, it will return the value it will return saying that the value was not found. Okay, so I is equals to initialize I is equals to 0. Is less than numbers dot length. I excuse me. We're gonna say system out print numbers array I. Okay, so I'm gonna prompt the user to put in a value. So okay, so we're gonna say key equals scanner next and then here is where we create now our binary search method. So we'll make that public static int. Oops, binary pass in the array, and array numbers, and then I'm going to also pass in the key, so key. Okay, so we need to return -1. Alright, so what binary search basically does is, let's say you're given a dictionary and you're looking for a word or whatever you're looking for. You can either flip through the whole book, which is what we say is linear search. So like from the beginning to the end, or the end to the beginning. That's too time consuming. So we use binary search. As long as the data you're given is sorted in ascending or descending order, and then what you do is you split. I'm going to use a dictionary book example. So you split the book in half, and if you know what you're looking for is, let's say, okay, if the mid page, right, let's say the value at the mid page, right, let's say you know that it's going to be either greater than or less than the value that you're looking at, and if you know which one it is, that will determine if you will search through the left side of that book or the right side of that book. I hope that short explanation, it's not even a full explanation, but I hope you can kind of understand what I'm going at with it. But anyway, let me code. Okay, so we're gonna have to initialize let's say low, set it equals to 0, and let's say low, and then mid, initial that to 0, and then high, high equals to let's say high equals to the numbers array length minus 1, because the length of the array is in this example is 8. The length is 8, so 1, 2, 3, 4, 5, 6, 7, 8. And we want 7 because we know that array the index starts with 0 all the way to 7. That's why we have number dot length minus 1. Okay. So we're gonna have a while loop, and we want this while loop. A while loop is always gonna be true. So we're gonna say, okay, while excuse me, while high is greater than or equals to low, and then we're gonna initialize high equals. Now here's the trick. High is always going, or excuse me, not high, mid. The mid is always going to equals to high plus low. Put it in a bracket so it has priority, and then divide it by 2. And that way it's always throughout the array. So what it's going to do here is take the low, and now we say the high is equals to 7, right? So what it'll do is take 7 plus, 7 plus 0, divide that by 2, which is 3.5, right? But what I don't know how to explain, but in the it won't be 3.5, it'll be 3 because it'll be 3 because you cannot have 3.5 here. And I'm sorry, I'm not really good at explaining. I just learned this like a few days ago. So anyways, okay, so mid equals high plus low divided by 2, and then what you do, you say while, okay, that, okay, now you say if, we have an if statement, so if, we're going to have an if-else if statement, a loop, statement, loop, I'm still new at programming, so okay, so if, let's say, array, so number, mid is, let's say, less than, or equals to, less than, it's less than, so if the mid is less than, if the mid is less than key, if mid is less than key, so mid here, let's say, is 11, right? And our key, let's say, just two numbers. Okay. So let's say mid is 11, right? And the key that we chose, that we're looking for is, let's say, 45, 32, or 87. So if mid is 11 and mid is less than, mid is less than key, right? So what it'll do, right? We want to have it where, if that's the case, we will then assign our new low to be this index. Alright, so we'll say we'll say here, if that's the case, we will say low is equals to mid mid plus 1. Right, so what that does is, now our mid is going to be, our low is going to be this index, which is index 6. Yeah, 6, and our high will still be the last index. And then we want to create an else if statement if that's not the case. I'm trying to make it tidy. So else if numbers mid is greater than key, we'll say that high, now we're going our high equals, we'll say mid minus 1, so mid minus 1. So again, we have our mid at 11. If our mid is less than the key, so let's say you picked, the user picked a key, and the key is, let's say, any of these numbers, so from 2 to 10. So what you do is take the mid, you minus 1, and then now this will be our new high. Okay. And then after that, we want an else statement where it will just have, so if none of these are the case, you just want else, return mid. And this is basically the algorithm for binary search using iteration. Excuse me. Okay, so let me bring up. So the next thing now we want we want to say, okay, key index equals binary search, and we're going to pass in the numbers and key. Okay. So we say if binary, spelled this wrong. Okay, binary search. Okay, there we go. Key index, key index. Okay. Oh, I gotta close this off. So here we have our if statement. So we say if key index is equal to -1, meaning that we do not have a number or a key that matches what we have in our array. What'll print out is number not found or key not found. So we'll say key was not found. We'll say else. Else if it was found. We'll say found key at index, in the index, so key index. Okay, key key variable, not use capital K. Okay. So let's play this or run it. Oh, I have to. Where is it? Okay. There we go. Okay, run this again. Okay. So I'm gonna put in 4. This is font 4 at index 1. So remember, I'm sure you already know, we have 8 elements, but the index starts from 0 to 7. So this is all index 1. And I'm going to run this again. I'm going to choose 11. And we get that. And let's just say 32. Get 5. And let's pick a number that's not even there. And you can see here it says 44 is not found. Okay. So the trick is basically for binary search is when you have data in our array, you always have to assign a low and high. In order to get the mid, you have to take the high plus low and then divide it by 2. But you have to put the high plus low inside a bracket. And that way it gets priority. You divide it by 2 and that'll be a mid. And also have you will initialize low and mid to 0, and then the high is always going to be not always going to be, but we'll just say high since we haven't picked out the key. We'll say the high is the last element. So that's why we have numbers.length -1, and then we have a while statement that is going to evaluate to true. So high is going to be either larger or equal to low, and we say mid is equals to high plus low and divide by 2, and then we say if numbers or if the numbers in the mid array or the mid is less than key, we say okay. So let's look at this again. We say mid is less than key, right? So meaning that the key is gonna be greater than the mid. Excuse me. The key is gonna be greater than the mid. So we will have to then search through the right side of the array. So what it does is it only deals with this, and then from there we assign the new low. Now will be our mid plus 1. So this is going to be our new low, and this is going to be our high. So it'll keep searching for that key. So what it'll do is it'll keep dividing in half. So it'll pick a new mid, and then it'll compare is a mid greater than or small or less than the key, and it'll keep doing that until there's only one value, or excuse me, if he hasn't found the key, it'll keep doing that until eventually it runs, or it only has one value. So that's where this comes in. So again, for here, when we have the mid is greater than key, meaning that the mid is greater than key, so that means it's going to be on this left side of the array, and that's why it's important in binary search to have a sorted array in ascending or descending. That way you can always compare from left to right. So yeah, and then from here, so if our mid is greater than the key, we'll then now assign the value right next to or before mid. Before mid will be our new high, and this will be our low. And if none of these is true, it will just return mid, meaning that the value is, well, no, if it'll keep doing that until it goes to mid. Oh, it just return mid, sorry. Now I'm confusing myself. But yeah, that's just basically the algorithm for binary search. I'm a student, so I'm probably like butchering through the explanation, but it's really if you write it down on paper and you go through it, it's pretty straightforward to understand. I hope you guys like this. It's a pretty long tutorial, but I hope I will show you a little bit shorter. But this is like my first time making videos, so alright, thank you. I hope this helped.